Hi, I'm DJ Ware, and this is the Cyber Gizmo. So, Intel just released their Lunar Lake mobile CPUs, but what aren't they telling us? So, beyond the specs and the press release, we're going to dive into some key features and that set Lunar Lake apart from its predecessors. I learned a long time ago when listening to marketing presentations, sometimes it's just as important to listen to what they don't say as to what they do say. Meaning, there's a lot you can glean from the fact that they skip over something. For example, for one reason they might skip over a feature is because the product doesn't support it, or worse, it was something they promised, but it turned out so bad they're not going to offer it. And they're hoping that you just forget about the whole thing. So yeah, those are two things you look for in a presentation to see, did they gloss over something? Did they kind of skip over and didn't show anything? Yeah, those are indications of weakness in the product that they know about. They're not so subtle, are they? So next, but not related to marketing at all. So how does Intel's decision to remove hyperthreading actually affect the performance? So, what's going on under the hood with their expanded branch prediction? And that might be a game changer, and it might not be. We're going to uncover how these CPUs push beyond Intel's own announcements and what that means for your next device and my next device. Plus, we'll explore a critical question. Can Intel restore the trust that it lost with the problems that we all encountered that use 13th and 14th gen CPUs? Let's talk a little bit about the design first. So, the Lunar Lake CPUs have been designed with an emphasis, obviously, on compact efficiency. We're talking about power efficiency. And that continues what Intel started in Meteor Lake. This is an innovative architecture, though. It has a small form factor, it's coupled with cutting edge materials, and that ensures a better power efficiency while delivering high performance. That's their goal. So, Lunar Lake is the culmination of Intel's IDM 2.0 strategy of 5 process architectures in 4 years. Why? This is 18 angstroms, which is the last in the 5 processes of what they hope to achieve. What about the hardware? What can we learn about it? So the Lunar Lake CPU lineup comes in 3 different models, major models anyway. There's the Intel Core Ultra 9, the Intel Core Ultra 7, and of course the Intel Core Ultra 5. Those models offer hybrid architecture with performance and efficiency cores, and the memory on Lunar Lake is not upgradable. They're offering currently, now I don't know what their plans are long term, but currently you can get either 16 gigabyte or 32 gigabyte LPDDR5X as an option. As far as thermals are concerned, Intel has made significant improvements in the thermal management with Lunar Lake, even over Meteor Lake, Meteor Lake was pretty good. And Lunar Lake continues with that. It tries to ensure that it keeps things cool and quiet, even under heavy workloads. That's their goal. Again, I haven't tested it. So we're just talking about what the spec says it should do. As far as cooling optimizations, there are hints that are sent to the operating system in order to know what state the CPUs are in, such as, are they in cooldown? Have they been warmed up? Have they reached a warm up temperature? And then there's also, have they reached hot? Is it hot? And those are things on the two ends you want to avoid, hot and cold. Yeah, it's called the Goldilocks. You want it in the middle where it's kind of warm. That gives you your best performance to start your workloads on. So the new architectures and cooling optimizations are designed to reduce the amount of heat that's generated by shutting down and turning off transistors that are not in use. So, and that also gains battery life, and it also prevents any kind of performance throttling that might occur because of heat and extended use, right? So, although, like we said, the memory on the Lunar Lake is not upgradable, after purchase, these processors offer expandability through Thunderbolt, PCIe, and so forth. So, I mean, does this future proof it? Some to some degree, but I think you're going to have to do more planning up front as to what you think your memory requirements will be. Let's say you're keeping your laptops for 8, maybe 10 years, maybe longer. I don't know, until the thing dies. But you want to plan for a certain amount of bloat that occurs in operating systems naturally. So, yeah, they grow over time. That's just the way things are. We add features and we don't take things away. So, future proofing these systems are going to require the right amount of memory. I hope Intel offers additional RAM capabilities to the system to give us more options for RAM as well. So, Lunar Lake supports a total of 8 PCIe lanes. And you're probably going, what? That's it? Just 8? That's right, just 8. And those are divided into two groups. One is 4 of them are dedicated for PCIe Gen 5, and the other 4 are dedicated to PCIe Gen 4, is the way I understand it. So now, Meteor Lake, in contrast, had a total of 28 PCIe lanes. So if you're considering a laptop, check the specs of them, because some of them I've seen shipping with only PCIe 4 NVMe slots. And there are others that have PCIe Gen 5. So if you compare this to an AMD HX370 chip, those support 16 PCIe Gen 4 lanes, and all 16 of those are usable. But when it comes to performance, Intel's Lunar Lake CPUs have had major changes. So, and I think one of the key shifts is the removal of hyperthreading. And you're probably going, why did they do that? It's gonna suffer in performance, and you would be absolutely right. Yes, it will. Hyperthreading does increase the performance of the CPU. However, they soak those processors and make them more energy hungry as well. So yeah, I think that's the main reason. Now, Intel hasn't come out and said, well, we got rid of it because we wanted to save battery life. But in actuality, I think that's probably the reason behind it. So, one question I still have is, what happens to your performance when you unplug your power supply and run entirely on battery? So, in the past with x86, there's a noticeable drop when you do that. It's like it goes into a mode where everything slows down. However, one of the strengths that Apple has is that if you do that on an Apple PowerBook, or it doesn't slow down when you do that. It stays at full bore, and it just runs along and uses the battery instead of the power. So I think it's because Apple, I think the way, if I remember correctly, they draw from the battery all of the time. So losing power is just going to mean that the battery is going to drain, and eventually you'll run out of power. But it won't. It will if you turn on the options. Once it reaches like 30% of capacity, then it will start throttling back your machine. But if you have good amount of battery that's left, it won't do that. But like I said, x86s historically have just, yeah, they've gone almost to sleep trying to sip that battery as much as they can. So one thing I noticed on the Qualcomm Snapdragon, I'm beating up on everybody, aren't I? So one thing I noticed about the Qualcomm Snapdragon X Elite is that if you unplug it from the battery, it just gets hotter. And I think what it's doing is, one of the big consumers of electricity out of the battery is the fans. It is an electric, and I did notice that when I go to plug it back in to power it, that fan ramps right up and starts blowing hot air out the sides. So until the temperatures come back down to where it wants to maintain them with the power. But you can try that on if you have one, try it and see what you get. That it could be that I might have inadvertently tripped the power setting, but that's what I'm seeing, and I have seen it like that since day one. I have not tested this on Lunar Lake again because I don't have one. I do notice though on the Meteor Lake, it will slow down a bit. So let's talk about the CPUs for a moment. So you obviously have two types. There's the P cores and the E cores. P cores are codenamed Lions Cove. The E cores are codenamed Skymont. And there's some pretty big architectural changes that they have done over the P and E cores that were implemented for Meteor Lake. So if you did a side by side comparison of the two core types, I think it would illustrate the different roles in processing that these two processors are designed for. For example, the P cores are designed for heavy workloads like gaming or heavy computation, where you absolutely have to have the fastest speed out of that processor you can get. The E-cores are designed for kind of a background processes and AI processes that can kind of loaf along a little bit and complete whenever they're ready at a reduced amount of performance, right? So they have done more with the E-cores to make it more responsive to like AI workloads, for example, so that it performs better with those. That since it's going to favor them, they've added additional things and features to the E-core to allow it to handle those things. We need to talk about Linux. So, where is Linux in the porting scheme of things? I think you're going to find that this is going to be a lot like it was for Meteor Lake. So the initial support for the Lunar Lake CPUs is in kernel 6.11. So if you want any kind of functionality with your machine, you're going to have the 6.11 kernel. Otherwise, you may not even be able to boot it, or it may just do weird things and stall. But yeah, and then so what's missing? What's missing is always what's missing: your Wi-Fi support and your graphics card support. There, I saw some mention of audio as well. There was a couple of things about audio that seemed like they still needed to be worked on, and so those are currently slated to go into 6.12. So, and by the way, 6.12 should be, unless Linus changes his mind, that should be the first long-term support release that we've got since 6.6. So yeah. So anyway, but 612 isn't even in the. If it is doing anything, they're taking their initial changes to 612 right now. It should start appearing in the release cycle somewhere around mid October or so, and then finalize sometime in November for release. So you'll see probably release candidates coming out for it, maybe as early as mid-October. Again, it depends on what they find, and if it could come out earlier, it could come out later. It just depends. So anyway, I'll keep an eye on it for you and let you know. I guess the other question is, what about the big guys? What are they doing? So what about Ubuntu? What about Fedora? What are they planning on doing? So Canonical hasn't made any public announcement that I'm aware of about support for Lunar Lake yet. But it would seem logical that they would probably use 6.11 for their build that's coming out in October. That would be 24.10. That, of course, is an interim build. It's supported for 9 months. But anyway, it'll give people an early chance to look at it. And who knows? I mean, they do update those more frequently than they do the long term releases. And so it's possible that 612 could go into that build as well. Again, I'm just speculating. I don't have any information in front of me that says, here's the roadmap, here's what they're planning to do. I don't know if they're planning to do any of this. Similarly, Fedora, also known for adopting new Linux kernels rapidly, probably will support. I mean, they'll support 6.11. They may even come out that with that in 40. Who knows? But they probably will support 6.11 and 41. If not, they'll add 6.12 at some later point. They're pretty good about that, and they don't seem to have a problem with just doing it and until, yeah, as they see fit and a need to be able to support it, which they will because that is supporting hardware that's brand new. I think one of the comments that I have is that both Intel and AMD have had established dedicated teams that work with the kernel team directly for many, many years. They have worked together with them. So they have a way of being able to manage the changes. They start months ahead of the release schedule of when even the announcement of the CPU, and they'll put an NDA on the development team so that nobody is communicating what the changes are and what the features will be until they've either announced it or officially released the product. And AMD is no different. They do the same thing. They'll work also with it. Now, Qualcomm could improve their Linux support, and one of the things they just did back in May was they became platinum members of the Linux Foundation, which of course gives them a seat on the board to help direct what gets done. They joined that in May of 2024, and that's great. I think that will help Qualcomm in the long term, and I look forward to seeing what they do with it. So Intel faced significant challenges with the 13th and 14th gen CPUs when users began reporting instability caused by what a lot of them thought didn't know what was going on initially, and they thought maybe the CPUs were defective, and so they sent them back for repair or replacement. And it turned out, as time went on, they found that it was an a overvolting problem that was generated by the firmware that was in the microcode. So, and that was causing not only for the CPUs to crash, but overvolting can also damage the electronic components. They were seeing erosion in the FETs, and damage to the FETs because of the overvolting condition. It was actually damaging them. So that would lead to permanent CPU failures, and there were a number of those, I believe. So Intel took a long time, and this is the perception of us, not me, but of us, who thought it took a long time for Intel to respond to the problem. Intel did release a microcode patch, and they extended the warranty on the processors for up to 5 years, hoping that that would regain the trust of all the users that were using 13 and 14 gen and could have been affected by it. Because you don't know, right? If the overvolting is one of those problems that if it occurs, it could show up as a failure 6 months later. You just don't know. It's a ticking bomb that goes off on its own. I have been personally experienced with that kind of a problem, so I can kind of appreciate what the Intel engineers likely went through. My first job at Burroughs, I worked with a customer who had just purchased a new mainframe, and it was failing in unpredictable and intermittent ways. It was crashing just at random. It took us 4 months of going through everything. That machine was very complicated. So it's not, and just like the ones today are very complicated. Fetch, decode, execute, store. They weren't that simple. There was a lot more. They had pipelines and they had prediction pathways and they had look aside, and it was complex to try to figure out where the failure actually occurred. I'm not making excuses. I'm just saying the other problem was the type of failure that it turned out to be. We didn't have the instrumentation for in the field. The hardware guys they could look at several milliseconds. Now this is memory that had access times of around 14 and a half milliseconds or so. I mean, it's pretty slow, way slow by today's standards, but back then that was considered state of the art memory. Yeah, kind of funny, huh? So, yeah, and they didn't have the tools to be able to measure what the actual access time was. As it turned out, we finally got a agreement from the plant to send out one of their engineers with a piece of hardware, very expensive hardware, that he brought with him in order to diagnose this particular CPU. Now, it wasn't a chip. This CPU occupied about 8 or 10 boards and was wired into a black backplane with probably 100 miles of wire in it. So, yeah, I mean, yeah, going in and trying to fix the microcode in that would be an ordeal because you have to reprogram it with the wire. Yeah, so not fun. So, as it turned out, it was, I believe, this is what I recall, it was CPU was picking up, instead of what it thought was program to execute, it was picking up data that had been stored in that memory location previously. So it was trying to run it, and it was getting an illegal operand. It was blowing up. So and that was the cause. Once we replaced that chip, I didn't replace it, the hardware guys did. But once they replaced that chip, it worked. But in order to make sure that the customer was satisfied, what we did was we rolled down a new machine and we put that in place, and we took back the other one, and the new machine was slated to go into our development lab, and so we just gave them our development machine, and we took theirs, fixed it, and used theirs as our development machine. It worked fine for us after that. But we didn't want to find another kind of error with another chip down the line, because that would have probably been it for us with that customer. It takes you can yeah, you it takes really good communication on a daily basis to keep the customer in the loop. What are you doing? What have you tried? What was the success? What was the failures? What did you see? What did you learn from it? Where are you going next? It was, this is our plan. This is what we did. This is what didn't show us what we needed to see. And we kept the customer in a loop. For 4 months, we did that. It was painful. So I can understand that that kind of a problem can take quite a while to find. Intermittent problems, hardware wise, especially like that one, are just treacherous to try to find, um, because you could see the symptom. Maybe you could see the high voltage, but what was causing it? Because that's where you got to go fix it. As it turned out, it was a piece of code that was wrong, and that's what Intel fixed. In summary, the Intel Lunar Lake CPUs, I think those represent a leap forward in both performance and efficiency. I mean, they are definitely in a class of their own. There is no other machine that I'm aware of that is trying to, no company that I'm aware of anyway, that's trying to produce a computer that's doing what that one is intended to do. Now, if you're a gamer, you're probably going to wait for Arrow Lake, and that's slated for sometime mid-October, and then release. They'll announce it mid-October and then release it sometime in November, probably late in November. So yeah, like they did. Well, I don't know. They didn't announce Meteor Lake until around the 14th of December. So who knows? It just depends on how their testing goes. So anyway, if you're a gamer, you're probably going to wait. If you're a content creator, a professional, and you need these machines for doing heavy lifting, but not super heavy lifting that like a gamer would need, uh, maybe that's the right thing for you, and maybe that's the right machine for you. They're not carrying the price tags that the big ones do, and it's not likely that you're going to see integrated. I don't know, I'm guessing, but it's probably not likely that you would see integrated discrete graphics engines from NVIDIA or AMD embedded into the systems as well, because they're just not designed for that. They don't have the PCIe lanes to support it. So, but I mean, there's always a reason and a use case for any kind of a machine. It just may not be for you. And with that, that's all I had for today. I hope you enjoyed this video. Please like and subscribe. Thanks for watching. Hope to see you again soon. And on that note, bye for now. I'm running away. Bye for now.